All right, I'm going to work out a few examples with you today. Now, what you see on top here, you have your reciprocal identities, you have your um, quotient identities, and you have all three of your Pythagorean trig identities, which have been rewritten three different ways here for you. So you can see that you might have to use one of those three as you continue on. And so let's look at number one. You have simplified the expression. This is considered to be a trigonometric expression. And what we're going to do is we're going to replace either one or more parts to this expression. So cosecant x is going to be replaced as 1 over sine x. So we'll take that and we'll also replace tan x with its quotient identity, which is sine x over cosine x. Now, once we do this, we can go ahead and use our algebra skills and cancel out the numerator and denominator to those fractions, and we'll end up with 1 over cosine x, but we're not going to leave it like this. We're going to go ahead and look at one of our identities up above. It looks like 1 over cosine x is equal to secant x, and that would be your final answer. All right, let's look on to example number 2. We've got sine x times this binomial that contains cosecant x and sine x. Now, sine x times cosecant x is sine x cosecant x. And sine x times sine x is sine squared x. Pay close attention to where the 2 is located. All right, so at this point, I'm going to look at this and say, okay, I can take cosecant x and replace it with the reciprocal 1 over sine x. So we'll leave sine x alone here. Replace this as 1 over sine x. And keep this the same. Here we go. So now we're going to be able to cancel out, reduce the numerator and the denominator. And all we're left with is 1 minus sine squared x. Now we're going to continue to simplify because all of this entire binomial, is equal to cosine squared x. So we're going to make that replacement. This is equal to cosine squared x. That's your Pythagorean identity. So we'll box this up, and that is your final answer. Next example. Here's a problem that contains a fraction. Now, if I decide to replace tan squared x, I'll do that on the side here, tan squared x with sine squared x over cosine squared x, that's fine. But then I'll also replace the denominator, and what I'm looking at is a complex fraction. And I get 1 over cosine squared x from secant squared x. And this complex fraction is not that bad. Notice that they have the same trigonometric functions. We're working with the same trig functions. I'm going to go ahead and keep that first fraction as sine squared x over cosine squared x the same. I'm going to change the division to multiplication, and I'm going to flip that last fraction so I have cosine squared x over 1. And by doing this, I see that I can reduce numerator denominator, and this simplifies to sine squared x. So that means that this entire fraction, all this work on the side, shows me that this fraction simplifies down to 1 minus sine squared x. And we just saw this in the last problem, that Pythagorean identity, that this is actually equal to cosine squared x. So this is our final answer. All right, let's move on to one more problem. So let's take a closer look at this. I have sine x times tan x, and it looks like the only thing I could really replace is tan x. So I'll go ahead and do that. So I'll have sine x times, let's do this, sine x over cosine x. And that will be plus cosine x here. Now, I'll go ahead and multiply these two together, and I'll have sine squared x over cosine x plus cosine x coming from over here. But I'm going to go ahead and place that over 1 because what I'm about to do is combine these two fractions. Now I'm going to have to make sure that I have a common denominator. It looks like the LCD, the least common denominator, is going to be cosine x. So I'm going to go ahead and multiply this second fraction by cosine x over cosine x. And let's go ahead and multiply those together. So I'll have sine squared x plus cosine squared x over cosine x. Now I have the same denominator. This means that I can go ahead and combine these fractions together. However, these are not like terms, so the only thing I can do is express them as a binomial. I can express it as one fraction, and so I have sine squared x plus cosine squared x over cosine. Now look close at your identities. This still looks like we can simplify it even more. Your Pythagorean identity, this entire binomial is equal to 1. So we'll have 1 over cosine x. And again, we're not going to leave that as a fraction. Look at your reciprocal identities and see that you can replace this with secant x. Okay, I only have 2 more videos for you today. We'll do number 9. We're going to replace secant x and tan x using the reciprocal and the quotient identities. Okay, so we're going to have cosine on the numerator, cosine x. On the denominator, I'm going to rewrite that as 1 over cosine x, and tangent will be replaced with its quotient identity, which is sine x over cosine x. And now take a look at these two fractions. We can add them because they have the same denominator. So on the numerator, we'll have cosine x. On the denominator, we'll have 1 plus sine x over cosine x. And now we have a complex fraction. So I'll go ahead and rewrite that here. We'll have cosine x. We'll take the division sign, and we'll rewrite it as multiplication times the reciprocal. We'll have cosine x over 1 plus sine x. All right, now if we multiply straight across, what you're going to find is that cosine x times cosine x is cosine squared x, and on the denominator, you'll have 1 plus sine x. Now, it looks like you might be done, but you're actually not done. We're going to continue this. We're going to replace this using the Pythagorean identity with 1 minus sine squared x. Now, at this point, I can't cancel out any terms. However, I can go ahead and factor the numerator. So when I see something like this, I think about how would I factor out this algebraic expression, 1 minus x squared, and I see, oh, that's the difference of 2 squares. And that's exactly what we're going to do in our situation. This 1 and sine squared x, that's the difference of 2 squares. So we'll go ahead and factor the numerator to 1 minus sine x, and then 1 plus sine x. So I normally look at an algebraic problem and say, how would I factor this? And then I do something similar with my trig expressions. Denominator will now cancel with part of the numerator, and we'll end up with 1 minus sine x as your final answer. All right, and the last problem here that we're going to finish is number 10. I'm going to go to a new page for that. Now we have 3 trig functions being multiplied here. I'm going to go ahead and replace this with its quotient identity, which is cosine x over sine x. And secant x I'll replace with its reciprocal, 1 over cosine x. And I'll go ahead and leave sine alone. So we'll have sine x. I'll place that over 1 for now. Now we can go ahead and reduce if we want at this point. And it looks like all we're left with is 1 times 1 times 1, which is 1. So this is it. If you have any questions, just leave me a comment.